Hi Spring fans! In this installment of Spring Tips, we're going to take a look at not one particular project and not one particular sort of concern. We're going to just look at some of the various utility classes inside of the Spring framework, inside of Spring proper. These are not to do with any one particular thing. As you'll see, we're going to go through a lot of different sort of use cases today. I want to just surface some of these because if you're using Spring and you want to take advantage of some of this functionality, it's already there. You don't need to reach for another library if you don't need it. And it may well be that the functionality you need is already in one of these utility classes. Now, that is not to say that you shouldn't use other libraries if they meet your use case. But I feel like surfacing some of these utility classes could be very useful. Now, we're going to look at all of this in terms of a very simple, just a straw man sort of example. So I'll build a new example here. We're going to call this the utility application. I'll give it a name, util examples. All right, and I'm only going to bring in Lombok, which is the Java annotation processor for compile time annotation processor. We'll bring in the web support because I'm going to build a web application later. We'll bring in AOP support because we'll look at Aspect.J and proxies. And that, I think, ought to do it. And again, I'm just doing this so that we have something with which to play and to exercise, right? So we're not trying to. The goal is not to look at how to build a web application today. It's to look at some of the utility classes. Okay. Now, the first thing we're going to look at is how Spring packages utility classes. How do we write that code? And the pattern is fairly consistent, right? If you look at a class like bean utils, right? Here's the Spring framework implementation of a type called bean utils. Bean utils is a class that we have on the class path. If we look at the source code here, it says that the class is abstract, right? So the class can't be instantiated. You're not expected to create any instances of this. There's no state, and then otherwise the methods are static. Now, we do, where we feel it's appropriate, signal that some of these methods are for framework use only. So you do well to look at the Java docs for this for these different utility classes. A lot of them are sort of common enough and they've been used in the framework for long enough that they're stable, and so you can benefit from them, certainly as stable as any other library out there. But keep in mind that we do reserve the right to change some of these things, and you'll see that pretty clearly sort of staked out in the Java documentation, right? So when you want to create your own utility class, you can consider this pattern, make it abstract, and then create static utility methods. The value of this is that there is no side effects, there's no state, and if there is state, then it's explicitly a singleton static kind of variable, right? All right, now let's take a look at our example here. We've got a utility example application, and we're going to build a class, just a simple class. That is a command line runner. We're going to have a bean of type command line runner, and the command line runner is going to be instantiated when the application starts up, and we're going to manage a particular class. We're going to have a simple strawman class, so we have something with which to work. So we're going to create a class called a demo class, right? Who cares really? It's going to be a component or a Spring. It's a Spring bean. Actually, let's make it we wanted to make it a data class because it'll be a Lombok type. We want to create a all argument constructor, so we'll create a constructor for that. And I want to have one field so that we can reflectively work with that for later on. So we'll create a field here, private final list of map of string of object, okay? And we're going to call this, it's a list here. We're just going to call this our list. And we don't really, I don't have anything particularly, I don't have anything in particular in mind when I design this field. I just want to have something with lots of generic parameters, right? A generic type. And this is going to be a private final field, but because we're using this Lombok Java annotation processor, we'll have the ability to call get list and set list on this class. It's a component. It's a Java bean property. So let's create an instance of that bean. We'll say demo class, and we'll just return new demo class like so. And there we are. There's our simple instance, our simple bean. We've done precisely nothing to it. We're just going to inject it there, and we can use it now. There's a lot of things we can do here. There's a lot of different things that you can imagine wanting to do with a simple bean like this. Maybe I want to confirm that the property list is not null, right? So already we can see a use case for one of the very convenient utility types that are in the Spring Framework itself. The assert class. The assert class has a bunch of methods, sort of like what you'd find in JUnit, to verify or to assert the state of fields, objects, whatever, before you operate on them. This is the design by contract, right? We're trying to put forward some preconditions and assert those preconditions are true before we operate on them. This makes the code that follows much more reasonable, right? You can understand that certain conditions are already true in order for you to be able to proceed to that line, right? So let's say that this field has to be there. So we'll say demo.getList, right? The list can't be null, right? So there's our first example, right? And let's go ahead and run this, and we'll see that the application spins up. We should be able to see the result be okay. Now let's change this a little bit. We'll call a setter on our oh, it's a final variable, so let's make it non-final so that the compile time processor will code generate a set list. And let's call null. Okay, now we should see that when we rerun this, it's going to throw an exception. Right? That exception, by the way, is an illegal argument exception. So you'll get that for free. Now let's see here. We wanted a no argument constructor as well. Right? So no argument constructor. Rerun that code. There we are. So when that application starts up, it says illegal argument exception, the list can't be null. So any code that follows that assertion must be true. You don't need to litter all the code with get if null checks and all that stuff. And the compiler won't even warn you about it because it'll know that that is proven for you there, right? So that's one convenient type, and we use this all the time. It's used in the Spring Framework itself all the time, right? Anywhere we want to assert the state of an object or to verify certain preconditions, we do so with the various methods on the assert class here. So there's methods here for checking checking whether an instance of an object is assignable to a certain type, checking to see if it's null, to see if the elements of a collection are null, to see if an object or a map or an array are empty, to see if an expression in general is true, to see if text is within another text, to see if text is empty or not, to see, that is to say, whether there's a value there. Lots of very, very convenient methods here. And there's just a generic one called state. So that just takes a boolean and a message. So if the state is false, then it gets you the message, right? So you can use these as you like. I think you're going to find that they're pretty darn convenient. Now, once I've got my my bean, I wouldn't mind inspecting it. Maybe I want to look at the properties on that bean, right? It's a Java bean. After all, it's got Java bean properties. It's going to have a getter for this list property. After all, so let's look at that. Let's create a method here called beans, and in the beans method, we'll enumerate the property descriptors in the application, in the bean rather. So we're going to say that this is going to take a demo class demo, and we'll put this in here demo. And there we can say bean utils get property descriptors demo dot get class, and this gives me a collection of property descriptors that we can then use. So I can say for property descriptor pd descriptors and let's log, right? So private static final log equals log factory get log util example application. Okay. There. So we can say this dot log or just log dot info pd dot get name. Right. So we should see for that one type a collection of different properties automatically being captured for us. Right. So let's see what that looks like if we run the code here. The bean is already defined, demo class. What have we got here? No argument constructor. Okay. So when I run this, I get the following properties. There's a getter. There's a property that I can access called class. Obviously, that refers to get class. And then there's a property called list. And so these are the Java Bean property descriptors. So I can actually let's see, PD. Okay, PD dot get a read method, for example, equals get read method dot get name, right? We know that in this case the interesting methods, the interesting properties on the Java Bean that we're inspecting right now don't have any write methods, so we won't bother asking for it. But you could test that, for example. So here the class, the property is called class, and the read method is called get list and get class, and that would hand you back a reference to the Java reflection method object, right? Okay, very good. So we have the Bean Utils, and that Bean Utils gives you a whole bunch of different sort of convenience methods to copy properties from one object to another, to find a property within a bean of a certain type, to instantiate an object based on a class, just to generally answer some very common questions. This is very similar, I think, to some of the functionality you might find in the Commons Lang Bean Utils type, right, which has been around forever. If you want to use that, that's fine, but there's a lot of the common things that you're going to need are here in Bean Utils as well, right? So there's one thing I can imagine wanting to do. Now, when it comes to just low-level reflection, as opposed to beans and Java Bean components and so on, there's some other things I'd like to be able to inspect as well. So let's rename this method to beans utils, and we'll create a new method here called classutils. And the classutils method will take as a chance to inspect at a lower level the sort of runtime state of the type using reflection, right? So let's say I want to get the constructor of that type. So I can say classutils dot get constructor if available, and we're going to say demo class dot class, and we have no parameters, right? We know that there's a no argument constructor, so let's say demo class constructor, and this dot log dot info. I guess it's just log to info. Demo class constructor is this one, and let's actually use this to create an object. So we'll say new instance, and there's no parameters here, so we'll create that as a we'll surround this with a try catch. We don't need more than one catch method in this case. Okay, and exception. There we are. So this is going to give me back an instance of demo class. So let's say log.info. We new instance demo class. Okay. Let's run this and see what we get. Okay. So there's my new instance object. It looks as we expected it to, right? There's a simple object that matches the makeup of what we're looking. It's got an empty array list, and it's an invalid state, and no exceptions were thrown. So that's convenient, right? We have the ability to sort of interact with that type we can do this using the raw class literal definition. We can certainly get there, but there's a lot of convenient methods in the classutils class. So for example, determining a common ancestor between two types, taking a collection of classes and turning them into a string, finding a class given a certain name and a certain class loader, finding all the interfaces in a given bean, getting the default class loader, getting a method, etc., etc., etc. Right? A lot of very convenient things happening there. Now, another very convenient type, another convenient utility class in the Spring framework is system property utils. And the reason we're going to use this is because we want to be able to talk about the location of certain files. So first of all, let's demonstrate system property utils just so we can, get a handle on that first. So here's system property utils. What we want to do is we want to resolve user.home. And if you know much about the way Spring Boot works, it maps all the environment variables, all the things that are in the environment, and all the things that are in system.getEnv and system.getProperties. It puts them into the Spring environment abstraction. The environment abstraction is just a glorified map of keys and values, and so things like user.home become injectable or resolvable as a property in the Spring application context. And the system property utils makes it very simple to create, to resolve placeholders in a string. So here, let's say my home directory is user.home. Okay, that's the string value. I'm using system resolved text. I'm using system property utils, and I'm going to log out the resolved text. Okay, and we say that and run this. Now we could of course just call system.getProperty in this case for user.home, but it's nice to not have to we can use the Spring property placeholder resolution syntax within strings here and get the right result. So that's very convenient. Now, I want to use that facility to create a file, and the reason I want to do that is because I want to now show another very convenient type in the Spring framework, which is the file copyutils type. So a lot of us have I'm sure you've written code that tediously copies and moves around, bytes from, A to B, or readers, moves data from one reader to another, or takes the data from a reader and turns it into a string. Lots of common, boring, soul-annihilatingly boring sort of input and output related things. So in this case, I want to look at file copy utils. So file copy utils. Okay. We'll create that method there. And in the file copy utils, what I want to do is I want to say file copy utils dots, and I want to copy the data from a reader into a string, right? So let's create a reader here, r new file reader, and the file reader is going to expect a file pointer naturally. Okay, and so the way we're going to build that file is going to use system property utils.resolve placeholder, and I'll just say user.home, and I'll point it to the desktop /content.txt, right? So if I look at this, this is a Java IO file, just a regular JDK type. Okay, come on. Good. There's my file. And the file reader is complaining because it throws an exception, so we'll catch that. Okay, new runtime exception, E. And now I want to get the contents of that file. So I'm going to say, even better, I'll just say I want to put that in there. Okay. Simplify this a bit. There we are. Now what I want to do is I want to log the contents. I'll say log contents of file, and I want to use file copy utils dot, and I want to copy the reader into a string, like so. Okay, so that's using the Java 7 auto closable feature. The try with feature, right? The ability to automatically close a closable resource, things like a file reader or an input stream or whatever. And as we do that, we can see that the contents of the file, it's equal to hello Spring tips, which jives with what we know to be true. So there's hello Spring tips on my desktop, and we can see the results. All right, so that's very convenient, right? We have a few other methods there. I'm sure you can imagine use cases for those as well. So file copy utils dot copy from one byte array to an output file, to copy from a byte array to an output stream, copy from one file to another file, copy from an input stream to an output stream, copy to a byte array, copy a file to a byte array, or copy an input stream to a byte array. A lot of very convenient data muling or byte muling kind of methods there. Okay. Now let's talk about some things that we can do, you know, to work with the web tier, right? What we want to do here is we want to work with the web tier and you know, inspect some things, or to work with HTTP servlet-based code. Okay, so I'm going to create a simple REST controller here. That's why I added the Spring Boot Starter Web endpoint to, or rather the starter to the application. So I'm going to say public static class simple REST controller. We don't care about the REST controller all that much in this case. And we're going to have a simple endpoint here called hi, and hi is just going to be a void hi method, and it's going to be a Spring MVC endpoint, right? So it's going to return nothing in this case. What we're going to do is we're going to tell Spring MVC to inject the servlet request. And again, I'm not expecting you to inject the servlet request. In fact, if you well-written Spring MVC code should absolutely never use the HTTP servlet request. You shouldn't need it, right? There's a lot of facilities in Spring that allow you to get beyond and to not depend upon the low-level servlet request. But if you're writing servlet code, if you've got servlet components, then it can be very useful to know that there are, you know, APIs that can make working with that code easy, even if you're not in Spring sort of environment, right? So here I'm going to say I want to get a parameter. Let's say I want to have an age parameter, right? So I'm going to say that servlet request utils dot get int parameter. I'm going to pass the request rather, and the name of the parameter is going to be the age, and I'll have a default value of 1, right? Or maybe 18, right? I don't know. So let's say that there's a, you know, we could even have a negative value. So we could say give us a negative value. So if it's, you know, we'll get a value, and if it's not something that was entered in the request, then we know that something was wrong, right? So here, log.info age is age. You know, we can do other things here. We can find out the web server's temporary directory as well. So we can use webutils dot get temp dir rather, and this takes the servlet context, and we can get that, of course, by dereferencing it from the HTTP servlet request like this. And this is actually a Java util file, a Java IO file, and we can confirm that as well. So temporary directory for Apache Tomcat is, and pass that there, so get absolute path. Okay, and we can also, if we're in a servlet environment and we're using Spring, and this is something you probably don't do in modern code, but if you've got really, really old, you know, excruciatingly old code, it's possible to hoist Spring up in a Spring application, and then access beans from component code that doesn't otherwise, you know, live inside of Spring. So if you have servlets and they want to talk to services that are managed by Spring, that context is called a web application context, and there's a very convenient method here, request context utils, that helps you find the web application context given a request and a servlet context. In this case, we don't need the servlet context. That web application context is actually an implementation of application context. So this is a Spring application context that you can use to now look up, you know, bean references, just like you would in very old Spring code. So here I'm actually just asking Spring for a pointer to the environment bean, right? The environment object that Spring maintains for you, and we can use that to whatever, I don't know, get a property here, right? So I'll get property user.home log.info web application context resolved property equals, and we'll just log that out as well and run that. If we run it, it's not going to, you know, we have to actually now invoke this. So what I'm going to do is I'm going to create a web method here that calls that endpoint. So in our command line runner, we'll just have a web method, okay? And I'll just create a simple REST template, rt equals new REST template, and I'll use the REST template to get a response, or actually just to trigger a call to localhost 8080/hi, and I don't really care about the return value here. I just want to call the service and confirm that when I call the service we see on the command line the output from these various utility calls. Okay, so let's see what that looks like. Okay, so the age is -1, so we didn't actually submit an age. We could have though, as a request parameter. The temporary directory is private var folders blah 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 tomcat dot whatever, right? Pointing to work tomcat localhost root, and then the web application context resolves property equals users JLong, which we saw earlier. So again, we're talking to our application, we're talking to our Spring services inside of a servlet API, inside of a servlet code base, which is very convenient if you're trying to do things inside of an application. Okay, there's some other conveniences here as well, right? What I want to do is I want to look at a sort of low-level perspective. I want to take a low-level perspective to objects that are managed by Spring's AOP mechanism, right? So Spring, makes it very simple to introduce business logic into an object declaratively in a single place, especially if you have cross-cutting concerns, things like transaction management and logging and auditing, whatever these concerns are. It's pretty simple to introduce these concerns using aspect-oriented programming. With the way we do this at runtime, the way the Spring Framework does this for you ultimately is that it creates a proxy, and it can do this a couple of different ways. If you're introducing behavior based on an interface into if you're introducing concrete behavior into a bean of a certain type of interface, then we can use regular JDK proxies, which have been supported for more than a decade in the JDK. Otherwise, we have to use something a little bit more sophisticated, something called a cglib proxy. So, being able to introspect and work with proxy beans can be very useful in some very obscure, granted, but still sometimes useful circumstances, right? So let's introduce a simple aspect, something that'll change the behavior of our application. So what we want to do is we want to have a method here on our demo class that's called when the application is initialized, right? Before the bean is put into service, we're going to have a before method right here, our setup. There we go. Or we'll just call this begin. There we go. Oh, that's something memorable, right? And in the begin method, all we're going to do is just log that we're working, right? So log.info begin. And when Spring starts up, this is going to be the equivalent of a initializing bean, so it'll call that method after the application has after the bean has been constructed, after all the properties have been satisfied via the constructor or setter methods. And what we want to do now is create an aspect that runs before this particular method gets called, just a trivial aspect. So I'm going to create an aspect here, public static class before aspect, a simple before aspect. And I want Spring to manage this bean, so I have to turn it into a component. This is not a stereotype annotation, it's more of a quality of other components in Spring. And we will create a aspect that gets executed before the execution of the begin method on any component, right? So we're going to, obviously in this case, we know that it'll only match our particular bean, our little demo class here, but I want to have something to work with here, so we're going to say when somebody calls the before method, pass in the join point, okay, and here we're going to just log.info before and log.info join point.toString, okay. And if that goes as we expect, then we should see that these two lines are printed out before the begin call ultimately gets called, right? So let's see that in action, just to prove that it's working. Okay, I must have done something wrong. Oh, I didn't introduce the AOP support, did I? null pointer bean utils. Let's make sure I've activated aspect-oriented proxying, right? AOP proxies. Nope, I still did something wrong. Let's see. We have a simple aspect that gets run on any begin method. Maybe I shouldn't do that. Let's get the signature. Okay. And we have a component here called begin. That looks okay. Let's see if that works. I think I may have just had a invalid reference there. No, it looks like I've done something silly here. Null pointer beans. Oh, we have more properties now. So there's evidently a property that we are not able to get a read method for. Indeed. So when we introduced the AOP framework, we introduced some types that get weaved into our code that aren't obvious unless you're doing sort of low-level reflection, because the proxies are ultimately runtime compatible with the types that we expect, right? They're objects that implement the same contract as the bean that we gave it to modify it, to weave, but it adds extra things. It's at the end of the day, it's ultimately a specialized class. It's a subtype that does some, whatever it needs to do to make it look like we've introduced this behavior without actually modifying the code, even though ultimately it does. So I'm going to go ahead and remove this because we're now tripping over some sort of property that doesn't have a read method. It might have a set method instead, but it's, we're not meant to call it. Okay. So when I do that, I am given the, let's see here. Yeah, everything seems to be okay. It's clear that the AOP support is working. Now, let's go ahead and inspect that. Let's go ahead and interrogate the status of all this. So we're going to use the AOP utils in Spring here. And I'll say that I want to get the class. I want to see if the bean here, demo class, demo. And I want to say AOP utils.get target class, demo class. And what this gives me is the actual bean, the actual type, the origin type, the source type, the raw type, the type that we put into it, and not the realized subtype that was created dynamically for us at runtime. So let me pass this thing in here, and we'll say that the class is target class, okay, log.info, and we'll ask it is an AOP proxy. We'll say AOP utils is AOP proxy. There's this, and we want to do the same for is cglib. We want to see if it's cglib specialized proxy. So again, knowing the difference isn't all that useful, but it might be something you want to do. So let's see how to do that. Okay, so there, it is both a AOP proxy and a cglib proxy in this case. That's very convenient. We are able to inspect that. Now we ran into an issue a few minutes ago that we were tripping up over a field that was introduced when we added AspectJ proxying, right, weaving. When we enabled that behavior, the aspect got weaved into our component code, and it created a mess that we weren't easily able to understand because there are fields that are not visible in the types that we're working with that are present at runtime, thanks to the sort of subtyping, the dynamic subtyping that happens behind the scenes. So it would be nice to have a way to sort of enumerate fields and methods and so on. So let's actually look at the reflection utils inside of Spring as well. So where's my command line runner? Up here. Good. We're going to use a new method here, call that reflection. We'll say reflection utils calling org Spring framework, and it gives us several convenient, several methods that make it simple to work with things that are potentially shaky or could cause trouble in certain objects, right? So maybe I want to find all the fields in a given class, right? So demo class.class, and it's going to ask me for a new field callback, and a callback is just a callback interface. It's like a template method that gives us a field, and there I can say log.info field equals field.toString. Okay, and of course this can be a Java 8 Lambda. That's, I think, very convenient. We can use the reflection utils as well to find a particular field in our class, so demo class.class. And in this case, the field is going to be called list, and we'll then have that, and that field is a Java lang reflect field, and I can now use this to I can inspect it and I can find out information about it. So log.info list toString, and I can log that out. But this is going to be of limited information, right? So we'll look in a second at something called resolvable type, which will give us even more information about this field. Okay. So it's a private final. Well, the field is equal to private. The one field that we found is equal to private final Java util list, of course. And then when we inspect that particular one, we get the same exact results. I could have done the same kind of thing with methods, right? So I can say demo class.class method log.info method equals, and say method.toString, and run this. Okay, and we can see here that we have a fair bit more code than we may have been aware. And of course, that's a side effect of both the Aspect.J support as well as the Lombok preprocessor, or, the agent, the compile time processor that's been introduced into our code. So we get all that for free, right? We get all these extra methods, even though we may not be particularly aware of it. So that's very convenient. We can see all this stuff, and we can see all that's been added to our class, and we can iterate all the methods in the class as well. Now I want to go back to this field. This field has a generic parameter, and so in order to understand more about that, I want to use the resolvable type, right? RT. I can say resolvable type dot for field, and I can pass in the list parameter here, and the RT. It'll give me the ability. It gives me the ability to find out what the generic parameter or parameters of the particular field are. So in this case, we know that it's a list of maps of certain generic parameters. So log.info rt toString, like this. Run the reflection method. Okay. And when we do that, we can see it shows us a Java list, Java util map, Java lang string, Java lang object. So it's aware of the generic types of our instance variable, right? Which is very convenient. And we can drill into that. We can say, give me a generic parameter for, get the generics, and then we can dereference a particular generic parameter. We can even then resolve it even further, and we can go, more. We can keep going. We can recursively go down and find the generic parameters and inspect them and so on dynamically, right? This is a very, very powerful thing to work with if you have generic types in your system. All right, let's see. So today we've looked at the bean utils. We've looked at class utils, system property utils, file copy utils, web some things that help you in the web, ALP support, reflection support. And these are just the beginning, right? There's actually a fair number of other ones that we haven't even had the chance to look at here. But I think you can, I think you should have the idea of what's possible, right? If you look, you're more than likely going to find something that may help you. So don't be so quick to rush out to bring in, yet another library. Not that we're discouraging you from using some other libraries. In some cases, you absolutely should. Some of these utility classes that I've just shown you here are not guaranteed to be stable, for example. So if you can find some other library that is going to make that guarantee for you and you're willing to carry the extra dependency, that's fine, right? Absolutely. But if you're just looking for some of these convenient methods, you may find that these are already on the class path and they've already been battle tested. They're being used by components in the Spring framework and the Spring ecosystem for a long time, so they're certainly usable and worthy. Hopefully they'll serve you in some way someday. And with that, thank you very much for watching, and we'll see you next time.